Okay, so let's talk about the graph of the quadratic function ax squared plus bx plus c. Okay, so before we talk about the graph, let's talk about the standard form of this quadratic function. So what is the standard form? So we will rewrite f of x as a times x minus h squared plus k. Okay, plus k. Okay, so we change ax squared plus bx plus c to this standard form of quadratic function. Okay, of quadratic function. And how to change to that form? We have a formula. So h is negative b over 2a, and the k is f of the output of negative b over 2a. Okay, b over 2a. Example. Okay, example. So let's look at f of x is, so let's say ABC is 1, 2, 3. Okay, 1, 2, 3. So x squared plus 2x plus 3. Okay, plus 3. So what is h? H is negative b over 2a. So this is a is 1, b is 2. A is 1, b is 2, c is 3, right? C is 3. So we got negative 2 over 2 times 1. This is negative 2 over 2, negative 1. Okay, negative 1. So h is negative 1. So what is k? K is f of negative 1. So this is negative 1 squared plus 2x. X is negative 1. Plus 2 times negative 1 plus 3. So this is 1 minus 2 plus 3. Okay, plus 3. So f of negative 1 is number 2. Okay, is number 2. So now we can write down the standard form. Standard form of this quadratic function is f of x is a is 1, so we don't need 1. X minus h is negative 1, so x plus 1 squared plus k. K is f of 1, so k is 2. Okay, k is 2. So we changed ax squared plus bx plus c to this standard form. Okay, to the standard form. We can use this idea hk to complete the square and to solve the quadratic equation. Okay, to solve the quadratic equation. So now let's try that. So we already did this. X squared plus 2x plus 3 can be changed to x plus 1 squared plus 2. Okay, so this is what we did last page. Okay, last page. So now if this is equal to 0, this is equal to 0. Okay, we change left hand side to a square plus a number. That's called completing the square. Okay, completing the square. Okay, so essentially we change this binomial to that square. Okay, to that square. So now we move negative 2, minus 2, minus 2. We got x plus 1 squared is negative 2. Okay, negative 2. And then we take positive negative square root. So x plus 1 is positive negative square root of negative 2. So x plus 1 is positive negative square root of 2i. Okay, square root of negative number means square root of 2 times I. There's an I for negative sign inside the radical sign. So now we have two solutions. So x1 plus 1 is radical 2i minus minus 1. So x1 is negative 1 plus radical 2i. x2 plus 1 is negative radical 2i minus 1 minus 1. So we got x2 is negative 1 minus radical 2i. Okay, radical 2i. Okay, so this is the modified completing square method. Okay, completing square method. So now let's look at another example. Okay, another example. So let's say we have 2x squared plus 6x minus 3 is 0. Okay, it's 0. So the new completing square method, step 1, change to standard form. Change the left hand side to standard form, a times x minus h squared plus k. Okay, plus k. Okay, so if we assume this is f of x, then h is negative b over 2a, and the k is f of negative b over 2a. Okay, negative b over 2a. So we imagine the left hand side is a function. Then we can change this function to the standard form of quadratic function. Okay, we find h and k using this function idea. Okay, using this function idea. Okay, so now a is 2, b is 6, c is negative 3. Okay, negative 3. And f of x is the left hand side, 2x squared plus 6x minus 3. Okay, so now h is negative b over 2a. Okay, so what is negative b over 2a? It is negative 6 over 2 times 2. So this is 6 over 4. So simplify that, cancel 2, so it goes 3 over 2. Okay, 3 over 2. So this is h. F of h. F of h. F of negative b over 2, right? Over 2a. So this is f of negative 3 over 2. Okay, negative 3 over 2. So what is f of negative 3 over 2? So we got 2 times 3 over 2 squared plus 6 times negative 3 over 2. Okay, and then minus 3. Okay, minus 3. So this is 9 over 4. So 9 over 2. 2 times 9 over 4 is 9 over 2. Minus, this is cancelled. You got 3 minus 9 minus 3. Okay, minus 3. So this is 2. So 9 minus 18 minus 6. So this is negative 15 over 2. Okay, negative 15 over 2. Okay, so now we can rewrite the left hand side as a perfect square. Okay, left hand side as this perfect square. So you have 2 times x minus h. So let's change the color. So the new left hand side is 2, this a, times x minus h. So x minus negative 3 over 2 squared plus k. So minus 15 over 2 is 0. Okay, it's 0. So nothing happened for the right hand side. Okay, right hand side. We just change the left hand side to the standard form. Okay, to the standard form if we look at this as a function. Okay, as a function. Okay, yeah. So now let's simplify this a little bit. So we got 2 times x plus 3 over 2 squared minus 15 over 2 is 0. Okay, it's 0. So now let's move this to that side. Okay, so step 2, move k and take positive negative square root. Then we got 2 solutions. Okay, then we got 2 solutions. So move k, then we got a new equation. Let's continue here. So 2 times x plus 3 over 2 squared is 15 over 2. Okay, divided by 2, you got 4. Okay, divided by 2 both sides. So we got 15 over 4 is this, take square root, positive negative. Then we got positive negative square root of 15 over 4. Okay, over 4. So x plus 3 over 2 is positive negative radical 15 over 2. Okay, square root of 4 is 2. So x1 is negative 3 over 2 plus radical 15 over 2. x2, you change plus to minus negative 3 over 2 minus radical 15 over 2. Okay, radical 15 over 2. Okay, so this is a new way to completing the square. Okay, to completing the square, you have to remember this h and k. Okay, this h and k. Okay, so let's try this one more time. Okay, let's try this one more time. So let's say we have x squared minus 4x plus 1 is 0. Okay, it's 0. So step 1, we need f of x left hand side change to x minus h squared plus k. Okay, plus k. So h is negative b over 2a, and the k is f of that, f of h, so f of negative b over 2a. Okay, over 2a. So we need a new left hand side. Okay, left hand side. So now what is a? A is 1, b is negative 4, c is 1. Okay, c is 1. So h is negative b over 2a. So this is negative 4 over 2 times 1. So this is positive 2. Okay, positive 2. So k is f of h, so it's f of 2, which is 2 squared minus 4 times 2 plus 1. Okay, plus 1. So this left hand side is our f. Okay, and then we change our f to this standard form. Okay, to this standard form. So this is 4 minus 8, negative 4 plus 1, negative 3. Okay, negative 3. So our new left hand side is a times, so it's 1 times x minus 2 squared minus 3 is 0. Okay, so that's our step 1. Okay, that's our step 1. We change left hand side to the standard form. Okay, to the standard form. And then now step 2, move k and take positive negative square root. Right? Move k divided by a, but a is 1, right? A is 1. So move k plus 3 plus 3. We got x minus 2 squared is 3. So now take square root. X minus 2 is positive negative radical 3. Okay, radical 3. And then we got two solutions. X1 is, so plus 2 plus 2. X1 is 2 plus radical 3. X2 is 2 minus radical 3. Okay, 2 minus radical 3. Okay, so after plus 2, you got x is 2 plus minus radical 3. Okay, and this is the meaning of plus and minus. Okay, plus and minus. Okay, so after practice, this part will be very easy. Okay, you have to know how to get h and k. So after you got h and k, you can change left hand side to this special form, where is the perfect square. Okay, so that's the completing square. X minus h is our square. Okay, it's our square. And then you take, move k divided by a, take square root, you got the answer. Okay, you got the answer. So this is the completing square method. We use standard form. Okay, we use standard form. So now the more important thing is we can use standard form to graph. Okay, to graph our function. Okay, so for any quadratic function ax squared plus bx plus c, okay, so we know the picture. The graph is either a parabola like this, it's like a U open up, or it's like an N open down. Okay, open down. So now there is a special point for this U shape. If it's a U open up, so this is called the vertex, which is the minimum of U. Okay, minimum of U. If this is open down, so we have this vertex. This is the maximum of this N. Okay, of this N. So what is the vertex? What is the vertex? Is h comma k. Okay, so now if you can change our function to standard form, you will get f of x is a x minus h squared plus k. Okay, plus k. Then you can know, okay, h comma k is either the minimum or maximum point of the parabola. Okay, of the parabola. Okay, yeah. So now it's open up or down, just depend on a. So if a is positive, the parabola is open up. If a is negative, the parabola is open down. Okay, it's open down. Okay, so first you need to know the vertex. Okay, and then based on the vertex, you know the parabola is open up or down, depend on a. Okay, depend on a. Okay, yeah. So now let's write down what's the y-intercept and x-intercept. Okay, how to find the y-intercept of a quadratic function. Okay, so y-intercept is on the y-axis. So x is 0. So it's 0 comma f of 0. Okay, so what's f of 0? F of 0 is a times 0 squared plus b times 0 plus c. So f of 0 is c. So this is 0 comma c. So y-intercept is very easy. Okay, it's very easy. So what's the x-intercept? X-intercept, you have to solve this equation. F of x is equal to 0 because the y part is 0. Okay, y part is 0. Okay, so this equation gives you solutions x1 and x2. So our x-intercept will be x1 comma 0 and x2 comma 0 if they are real numbers. Okay, if they are real numbers. So now we need these four informations to draw the graph of quadratic function. Okay, quadratic function. And another question is, sometimes they will ask you, what's the axis of symmetry? Okay, what's the axis of symmetry? So by definition, axis of symmetry is this vertical line. Okay, this vertical line is x is equal to h. Okay, is x is equal to h. So we need to know 1, 2, 3, 4, 5 informations. Okay, 5 informations. So now let's look at an example. Okay, very easy example. So let's say f of x is x squared plus 2x plus 2. Okay, plus 2. So we know a is 1, b is 2, c is 2. Okay, so step 1, find hk, the vertex. Okay, the vertex. Okay, so what is h? H is negative b over 2a, and then k is f of that. Okay, f of that. So negative h is negative b over 2a. So this is negative, b is 2. 2 times a is 1, so this is negative 1. K is f of h, so it's f of negative 1. So this is negative 1 squared plus 2 times negative 1 plus 2. So this is 1 minus 2 plus 2, 1. Okay, 1. So vertex is negative 1, 1. Okay, negative 1, 1. So this is the vertex. Okay, this is the vertex. So now step 2. We look at A. A is positive, right? A is positive, implies is a big U open up. Okay, and here is the vertex. This minimum is the vertex V. Okay, vertex V. Okay, yeah. So now step 3, before we draw the picture, we have to know x-intercept and y-intercept, right? So step 3, we got y-intercept is 0, f of 0. So 0c, okay, 0c. Or you can use the 0c. 0c, c is 2, so this is 0, 2. Okay, 0, 2. So y-intercept is 0, 2. Okay, 0, 2. So x-intercept, okay, x-intercept. So there are 2 ways to find it, or maybe 3 ways to find it if you can factor that. So my suggestion, you just use quadratic formula. Okay, quadratic formula, or you use the standard form. Okay, so step 3, find x1 and x2 for the x-intercepts. Okay, so x-intercepts is x1 0 and x2 0. Okay, x2 0. Okay, yeah. So my suggestion is quadratic formula. Okay, quadratic formula. So it's negative b plus minus square root b squared minus 4ac divided by 2a, right? 2a. So this is negative 2 plus minus 2 squared minus, so 2 times 4 times 1 times 2 divided by 2 times 2. So this is negative 2 plus minus radical. So everything under the radical sign. So this is this part is 4 minus 8, so it's negative 4 divided by 2 times 2, so it's divided by 4. Okay, yeah. So square root of negative 4, so this implies negative 2 plus minus square root of 4i divided by 4. So that implies x1 and x2 are not real numbers. So no x-intercepts. Okay, no x-intercepts. Okay, yeah. So the last step was the symmetry. Okay, what's the symmetry? X of symmetry. So step 5. X of symmetry is x equal to h. So this implies x is equal to negative 1. Okay, x is equal to negative 1 is the symmetry. Okay, is the symmetry. So this is the calculation part. So now let's draw the picture. Okay, let's draw the picture. So we know is a big U open up. Vertex is negative 1, 1. So negative 1, 1. So this is V, right? This is V. This is point V. Negative 1, 1. And we know it's open up. So this is our U. Okay, so I will change the color. The red one is our parabola. Okay, our parabola. So you see there is a y-intercept. So what's the y-intercept? 0, 2. Okay, 0, 2. And from the picture you can see, so this parabola and x-axis, they have no common point. So that means no x-intercepts. Okay, no x-intercepts. Okay, so now let's look at some cases, right? So you have a parabola. If this is the parabola, how many x-intercepts you have? 2, right? So x1, x2. They are both real numbers. You have two intercepts. So the second case, so draw a parabola. Maybe it's open down, but this is the vertex. Okay, so how many intercepts you have? Only this vertex. So x1 is equal to x2 in this case. And this is a real number, so we only have one intercept. Okay, one x-intercept. The last case. Okay, the last case is our previous example. You see, it's a big U open up, then there's no x-intercept. Okay, or you may have a big U open down, so there's no x-intercept. Okay, x-intercept. So that means solutions are not real. Okay, so this is x1 and x2 are not real numbers. Okay, are not real numbers. So this is the cases you may meet. Okay, you may meet. So now let's look at an easier question that can be factored. Okay, that can be factored. And we will try to find the vertex in the end. Okay, so because these five informations are somehow independent. Okay, so you can find x and y intercept first if it's easier. Okay, if it's easier. So now let's see f of x is x squared minus 3x plus 2. Okay, plus 2. So first you can find the y-intercept. That's the easiest one. Okay, I change the order. Okay, I change the order. So is 0, f of 0. So is 0c. C is 2. So this is y-intercept 0c is 0, 2. Okay, 0, 2. So step 2, we find x-intercept, x1 and x2. Okay? So x squared minus 3x plus 2 is 0. We can factor the left hand side. Product 2, sum negative. So this is product and the sum. Product 2, sum negative 3. So it's negative 1, negative 2. So it's x minus 1. X minus 2 is 0. So this is 0, give us x1 is 1. This is 0, give us x2 is 2. Okay, so we have two x-intercepts. 1, 0 and 2, 0. Okay, 2, 0. And A is positive, right? A is positive. So step 3, we know it's a parabola, open up. Okay, open up. So before we find the vertex, we can draw the picture now. Okay, we can draw a picture, but we just don't know the precise position for the vertex. Okay, vertex. So x-intercept is 2, or y-intercept is 2. So as a parabola passes this triangle, right? X-intercept 1 and 2. So here is 1, here is 2. So we need a parabola open up and passing these 3 triangles. So this is the picture. Okay, so let me change the color. We need a parabola passing the y-intercept and these 2 x-intercepts, and it's open up. So that's the picture. Okay, that's the picture. So before you calculate h and k, you already know the picture. Okay, you already know the picture, but we still don't know the precise place for this vertex. Okay, for this vertex. So now you can calculate the vertex. Okay, yeah. So if you got the picture first, it will be helpful to tell you, okay, h is negative and k is negative and h is between 1 and 2, right? Between these 2 x-intercepts. Okay, yeah. So now let's calculate the vertex. So h is negative b over 2a. So it's negative 3 over 2 times 1. So it's 3 over 2. Okay, you see it's 3 over 2, between 1 and 2. Okay, between 1 and 2. And the k is f of 3 over 2. Okay, it's a fraction. Okay, and you want to find the output for the fraction. Okay, so in most cases, h and k is harder than the y-intercept. Okay, sometimes it's harder than the x-intercept. Okay, yeah. So this is 3 over 2 squared minus 3 times 3 over 2 plus 2. So this is 9 over 4 fractions minus 9 over 2 plus 2. And change everybody to fraction with denominator 9. Denominator 4, sorry. So this will be negative 1 over 4. Okay, negative 1 over 4. So k is negative 1 over 4. So what's our h? Our v. Our v is 3 over 2 comma negative 1 over 4. Okay, 1 over 4. So vertex is this point. Okay, vertex is this point. And the symmetry, okay, you see there is a line. So our parabola is symmetric with respect to this line. So what is this line? X is equal to h. Okay, so the symmetry, x of symmetry is x is equal to h. So that implies s is equal to 3 over 2. So this is the line of symmetry. Okay, line of symmetry, vertical line of symmetry. Okay, yeah. So most cases, these 2 numbers are harder to find. Sometimes they are complex numbers, sometimes they are irrational numbers. Okay, so this is an easy step. This is an easy step. You know the y-intercept, you know the parabola is open up or down. Okay, up or down. And hk, okay, it's not that hard. Sometimes you have a fraction. Okay, you have a fraction. Let's look at one more example. Okay, one more example. irrational, x1, x2, right? x1, x2. So let's say f of x is negative x squared plus 4x plus 1. Okay, plus 1. So a is negative 1, b is 4, c is 1. Okay, c is 1. So first you can find the easiest thing, y-intercept. Okay, y-intercept. So which is 0c. 0c is 0, 1. Okay, 0, 1. And the step 2, you can use quadratic formula to find x1 and x2. Because nobody can factor it, you can try. Okay, product 1, sum 4. That's impossible. Okay, that's impossible. So quadratic formula find x1, x2. So x is negative b plus minus square root b squared minus 4ac divided by 2a. That's the quadratic formula. So x is negative 4 plus minus b squared, 16, minus 4 times a, negative 1. 4 times a times c, 1, divided by 2 times negative 1. Okay, negative 1. So x is negative 4 plus minus, this is 20. Okay, under the radical sign is 16 plus 4. So radical 20 divided by negative 2. So this is 2 plus minus radical 20. So we can change radical 20 to 2 radical 5. Okay, so divided by negative 2. So you got radical 5. Okay, radical 5. So we got x1 is 2 plus radical 5. And x2 is 2 minus radical 5. Okay, so we got these two numbers, but they are irrationals. So it's very hard to graph them. Almost impossible. Okay, almost impossible. So in this case, we can change it to decimals. Okay, decimals. So what is radical 5? Radical 5 is, okay, so radical 5 is about 2.2. Okay, about 2.2. So this is about 4.2. This is about negative 0.2. Okay, 0.2. So for bad cases, okay, for bad cases, x1, x2 are bad numbers, we can use decimals. Okay, irrational numbers, we can use decimals. So x1 is a little bit bigger than 4. And x2 is a little bit less than 0. Okay, less than 0. Okay, so now we know it's a parabola open down, so it's like an N shape, right? And the vertex is the maximum point. So this is the V. So now let's find h and k. Okay, h and k. So h is negative b over 2a. So this is negative 4, b is 4, 2 times a, so 2 times negative 2. Okay, so this is 4 divided by 4, 2 times negative 1, sorry. 4 divided by 2, 2, positive, so positive 2. And then k is f of h, so this is f of 2. f of 2 is negative 2 squared plus 4 times 2 plus 1, this is 5. So V is 2, 5. Step 4. And step 5 is x of symmetry. Symmetry is x is h. So this is x is 2. Okay, x is 2. So this is the calculation part for this question. Okay, for this question. So now let's draw the picture. Okay, let's draw the picture. So I'm going to delete the quadratic formula part. Okay, quadratic formula part. Let's draw the picture here in the middle. So for the quadratic formula, we already put the answer in step 2, right? In step 2. So now let's look at the picture. So first we know 0, 1 is the y-intercept. Okay, so here is 1. So the parabola has to pass this number 1. Okay, and then we know 2, 5 is the vertex. So here is 2 and go up 1, 2, 3, 4, 5. So we have to go up here. That's the V, so that's 2, 5. Okay, 2, 5. And x1 is about 4.2. So 3, 4. So it's a little bigger than, this is x1. Okay, it's a little bit bigger than 4. And x2 is a little bit negative. So this is x2. Okay, x2. and it's a parabola open down. So we have a parabola, pass x2, pass y-intercept, go to the vertex, and then go down past x1. Okay, x1. So that's the parabola. Okay, that's the parabola. So the symmetry, x of symmetry is this, is x is equal to 2. Okay, x equal to 2. So this is the lecture for graphing. Okay, lecture for graphing. You find y-intercept, x-intercept, vertex, and symmetry. Okay, symmetry for a given quadratic function ax squared plus bx plus c. Okay, plus c. Okay, so that's it. So that's our today's lecture.